Okay, so we're not going to do every proof in here. I am going to start with proof number 1 because it's just a baby proof, okay? So what I would want you guys to do is obviously write your given. All right. And if you look at your given, it does not look like you're given a lot of information, right? You're probably like, what can I even use from this? Where can I even go? But the fact that you are given, all right, that this is a parallelogram and this is parallelogram is actually very relevant because we know all 7 of these things, all right, about a parallelogram. It's all inferred, all right, within the fact that we're given that this is a parallelogram, okay? So if you look at what we're trying to prove, all right, that this segment of HJ is congruent to this segment of ML, okay? So here's what I want us to focus on. I want us to focus on this parallelogram first, okay? And so what do we know about that parallelogram? Well, we know all 7 of those things about parallelogram HJKP. We know that the opposite sides are parallel. We know the opposite sides are congruent. We know that the opposite angles are congruent, etc., okay? So if I'm trying to prove that HJ is congruent to ML, let's try to get this HJ in there somehow. So what I know is that this HJ has to be congruent to this PK, right? And that's how I'm going to write it. So I'm going to state that HJ is congruent to PK. And that's because opposite sides are congruent. Okay? All right, now let's look at this parallelogram of PKLM. Okay, well, what do we know about that parallelogram? Same idea. We know all 7 things. All right, so let's take a look at PK. Well, what do we know? We know PK has to be congruent to ML. So segment PK has to be congruent to segment ML, and that is by the same thing. Opposite sides are congruent. Okay, we're actually one step away because if you look at step 2 and step 3, take a look. We have HJ is congruent to PK, PK is congruent to ML. I can now hop to the fact that HJ also has to be congruent to ML. All right, and that is because of the transitive property. All right, so like I said, a little mini proof there. All right, just a nice, cute little 4-stepper. Okay, now step 2 is very similar to this one up here. All right, you guys could go ahead and try that one on your own. I do want to try, all right, this next one. Okay, it's a little bit harder. All right, but this last one is just a really good proof. It's kind of tough. So if you guys want to try that one on your own, you absolutely can. But I'm going to try this one right here and go through it. Okay. So once again, all right, we are given, it doesn't look like a lot, all right, but we're given parallelogram ABCD. All right, we're also given that DE is congruent to FB. All right, and let's just kind of mark up what we're given and then try to get a game plan. So we're given that DE is congruent to FB. We're given that this right here, ABCD, is a parallelogram. So this full thing right here is a parallelogram, okay? And what we're trying to prove is that angle 1 is congruent to angle 2. So if you can kind of game plan here, all right, I'm going to tell you what we're going to do. And what we're actually trying to prove here is that this triangle is congruent to this triangle. That's our game plan. Because if we can prove those 2 triangles to be congruent, what do we know about the corresponding parts of 1 and 2? We know that they're congruent. All right, so we're going to try to prove those 2 triangles to be congruent, and then we're going to use CP/CTC to state that 1 and 2 are congruent. So how do we do that, right? Well, how we do that is actually this major piece of information here, which is the fact that we are given a parallelogram. And with that parallelogram, we are given all of those 7 properties, right? So what do we know about the opposite sides? Well, we know that the opposite sides are parallel, but we also know that they are congruent, right? So we do know that DC has to be congruent to AB, but that's not helpful for us. What's helpful is for us to state that AD has to be congruent to CB, okay? And that's going to be my second step. AB, or AD, my bad, is congruent to CB. All right? And that is by the fact that opposite sides have to be congruent. So opposite sides congruent. Okay, so that's helpful. That's good. All right, we now need to look at what else do we have in there? Well, we don't really have anything to state that AE is congruent to CF. All right, that's not helpful for us. So what do we know about the opposite angles? Well, we know that the opposite angles are congruent. So take a look at angle D and angle B. Couldn't we state that those two angles are congruent? Yeah. All right, so I'm going to state now that angle D is congruent to angle B because opposite angles are congruent. So if we look at our two triangles, do we have enough information now to state that those two triangles are congruent? Yeah. All right, and we're going to do it using a little SAS, a little side angle side, okay? So I'm going to state that triangle DAE is congruent, all right, to triangle BCF, and that's by side angle side, okay? And then now that we've stated those two triangles are congruent, we can say that the corresponding parts are congruent, which means then that angle 1 has to be congruent to angle 2, and that's by our old friend CPCTC. Okay, guys, I'm going to do one more video. This one's kind of optional if you want. If you wanted to do, all right, this last proof, it's a great one, all right? And I will do a video going over it just so that you guys can see, you know, what that proof looks like, okay? So if you want to look at the last proof, you can. All right, if not, that's kind of the end of the lesson.